So, today is Wednesday. It is the last day of September. I know it's crazy that it's the last day of September already. Um, we have so far this week. You should have on Monday done a dual credit um, sign up through NTC. If you did not, there are some videos to watch in regards to that. Please do that very soon. Just because you signed up for the dual credit through the tech doesn't mean you have to accept the dual credit through the tech. Okay? Just signing up affords you the opportunity to get those 3 credits at the end. If you don't sign up, you don't get that opportunity. Okay? So it's good to sign up if you haven't done so already. It doesn't cost you anything. It doesn't require that you do anything other than sign up through the tech, and then that gives you the opportunity to um, get 3 credits of mathematics that you can transfer then to colleges and universities and that fun stuff. So, anybody have any questions on that? We'll get more and more involved with that in the spring when it becomes time for us to submit our grades there. So as of right now, we should be good to go with that. Okay. Okay. Then the second thing that you should have done this week, or so yesterday, we took the EMPT, the Early Math Placement test through the UW systems. If you haven't taken that test yet, there are instructions on its learning for you to take that and get that done as soon as possible. Most of you, I didn't look at the grades, but I think most of you were in the low C to D range of the scoring. It's scored D1, 2, 3, and then C1, 2, 3, 4, where C4 is the maximum of on the test. Don't worry about what score you got. All we use that for is it's our baseline. Okay, it's just a baseline test. There was a lot of stuff on that test that is going to be taught to you yet in this course. So don't freak out if you got every single question wrong. Totally fine. I've seen it happen before where everybody got all those questions wrong. It's fine. We'll teach you that stuff. That's just the baseline right now for what we're going to use it for. And it doesn't go in the grade book. It's not a grade that will ever come back to haunt you or to hurt you or to help you even for that matter. Okay? It's just a base so we can figure out what you've actually learned throughout the course of this class. Okay? So don't freak out about that one. All right. With that being said, let's dive into some notes. Lots of notes today, lots of writing today. If you didn't print out the note sheet that we had told you to print out, and I thought I had sent you an email about that, but so there's a note sheet for you to print out if you haven't done so already. But write down what you need and so on and so forth. Okay. So we're going to start by you not using a graphing calculator, and we're just going to sketch these graphs. And again, in your notes, it can just be sketches too. It doesn't have to be full-on, pristine, to-scale graphs. Okay, these can just be sketches of these functions. Okay. So we also need to identify the y-intercepts and the horizontal asymptotes of the graphs. Okay? So here we go. So if I had the function f of x equals 2 to the x power. If I wanted to, I could maybe, and just when I see that, then Look at that. That's funny. That's funny. Okay, here we go. So we can always make a t-chart based off of that. And so if I had 2 to the x power and I plugged in -2, I would get 1/4 as my value of the function. If I plugged in -1, I'd get 1/2 as my function. If I plugged in 0, I would get 1 as my value. If I plug in 1, I would get 2. If I plugged in 2, I would get 4. Okay? Then, when I go to put those on a graph, what I would do is, so over at -2 would be, oops, have breaks. Whoa, that's right, I forgot. All of this just got funky. So now I'm going to use these, and I'm going to use these. And so over at -2, I would be at 1/4. At -1, I would be at 1/2. At 0, I would be at 1. At 1, I would be at 2. And at 2, I would be at 4. And so my graph would come through like that. Okay. From that, I would have a horizontal asymptote because I would never be able to be negative. So I would have a horizontal asymptote like that. Okay. Do we think that this is a growth or a decay? Thumbs up for growth, thumbs down for a decay. I see lots of thumbs up. It is growing as our x's increase. So as we go to the right, the value of our function is getting larger and larger. So therefore, this is a growth. The y-intercept is the point at which our function crosses the y-axis, or when x equals 0, that is our y-intercept. And in this particular case, our y-intercept is the point 0, 1. Our horizontal asymptote is y equals 0. Okay. With that being said, what I'd like you to do now is I'd like you to do example number 2. G of x equals 2/3 to the x power. Quick sketch of that, and then we'll go over growth, decay, etc. So I get something that looks like that as my graph. Thumbs up, growth. Thumbs down, decay. Yep, we got a decay. Lots of thumbs down on that one. Y-intercept is at 0, 1. Horizontal asymptote would again be at y equals 0 there. Equals wasn't working the best. So there's our horizontal asymptote. That value of those two functions can never be negative. We can't put an x value in to make them go negative. Okay? Love it. Good times. Okay? So, some thoughts about the functions y equals a times b to the x power. Okay? So, if we're talking about b, that b value, that value here is what makes it be a growth or a decay. Okay? So we are growing if b is bigger than 1. If the value of b is bigger than 1, we are a growth type of function. If b is between 0 and positive 1, we are a decay type of function. Okay? In y equals a times b to the x functions, b can't be negative, can't be 0, and can't be 1. Okay? So b can't be negative, can't be 0, can't be 1. Okay? On those previous two examples that we just graphed, and you can use your hands for these. You can use one hand for one and the other hand for the other. What are the two easy exponents to evaluate in your head, or the easy, what values of x now, what values of x here would be the easiest ones to put into, I don't know why that arrow got all kinds of funkied up, okay? What would be the easiest value of x, or the two easiest values of x to put in? So one hand do one hand do the other, okay? Ready, set, go, okay? I see a lots of these, and I see a lots of these, right? So 0, putting in 0 for an exponent would be pretty easy, and putting in 1 for an exponent would also be relatively easy. Okay? So those two are the easy ones to plug in to our function. So being that we're in a higher level math course, that's the ones that we're going to focus in on. We want our exponent equal to 0, and we want our exponent equal to 1, because we want to make it easier on ourselves. Okay? For graphs of the form f of x equals a times b to the x, the y-intercept is going to be of the point 0, comma, well, if I plug 0 back into this equation, right there for x, if I plug 0 back in there, b to the 0 power, whatever b is, b to the 0 power is going to be 1. 1 times a is going to be a. So our y-intercept will always be the form 0, comma, a. If it's the basic type 1. And the horizontal asymptote will always be the line y equals 0. Now, if I take and I expand on that function, and I get all the different horizontal shifts and all the different vertical shifts and all the different stretches and all that fun stuff. Okay? So if I come up to f of x equals, I'm going to just rewrite it here for a second because then it's nice and big for me to add stuff in, times b to the x minus c, then plus d. Okay? So this, the b, that's going to be growth or decay. C is going to shift it horizontally. And D here, D is going to be our vertical shift. Okay? So then D there is going to be our vertical shift. And that's going to shift everything vertically. Okay? And so our horizontal asymptote will then get shifted. Instead of it being y equals 0, now it will be y equals d in that particular case when we have all of those shifts. Okay. Questions on that? Seeing none, let's continue. Okay. Let's jump into exponential functions with a base of e. These are higher level mathematics, uses base e instead of base b, just because it's nicer, it's cleaner, it has better rules. And when you're solving it, it has easier logs, which we'll get into later on this week. Okay? So the graph of the function f of x equals e, well, if I look at it, if e is 2.7, oh yeah, I got my highlighter. If e is 2.71828, so on, so on, and so on, then if I think about this one in terms of the old f of x equals 1 times 2.718, we'll call it that, to the x power, that tells me from what we just learned that that's going to be a growth function because my b value is bigger than 1. So I can graph that growth function. It's going to have a horizontal asymptote of y equals 0 still. It's going to have a y-intercept still of 0, 1. The other point that we would go through would be the point 1, 2.718. So we'd still have all of that. Okay? But now we just have to figure out if E is constant. So if E is locked in, it stays there, don't change it. How do we change from a growth to a decay, or from a decay to a growth in our exponential function? But before we do that, let's get the question of the day answered. The question of the day today is, if you had to get pizza from somewhere, where would you get pizza from? Okay, so favorite pizza place is the question of the day today. Okay, drop those in the chat. I did this with Algebra 3 too the other day, and overwhelmingly it was Polito's. Second place was Toppers, then Pizza Hut and Domino's, and then Angelo's and Wausau Mine were in that kind of order so far. Okay? So let's get back into it. How do we go about changing from growth to decay? Well, it's controlled by a variable k. Okay? So the growth, if k is, that's a bad k. Okay? So if k is positive, okay? So if k is positive, then we are in a growth situation. If k is negative, we are in a decay situation. And the reason that is the truth bomb, because is if we have E, well, E is 2.718, so on and so forth. And we take that to a variable, to an exponent. Okay? Well, if that exponent up here, if this is positive, then we have 2.718, so on and so forth. Okay? So for instance, it would grow. So if I had something along the lines of E squared, that would be 2.718 squared, which would be something approximately 8.3-ish. Okay? I don't really know it off the top of my head, and I don't really have a calculator anywhere near me. There's one way over there that I could use to grab to figure it out, but I know it's less than 9, but it's pretty close to 9. Okay? Now, if I switch that around and I make that be a negative 2, well, that's going to be 1 over E squared now to make it the positive exponent, which is going to be 1 over, let's say, 8.3, which is a smaller number. Okay? So it's that reciprocal rule to make that exponent be positive is why that positive k values make it grow, negative k values make it decay. So, kind of a summation of everything. Now, there's a lot of writing on this page, okay? And if you have the note sheet printed out, you can fill it in, easy on you. If you don't have the note sheet filled out, okay, you could probably just write down the stuff above the red line, okay? Because the stuff below the red line is me writing out what's above the red line. Okay? So, in a growth function for a regular old a times b to the x, b has to be bigger than 0. Okay? And so, in a regular f of x equals a times b to the, if b is bigger than 1. I think I said 0 first, but it should be bigger than 1. So if b is bigger than 1, okay, we're in a growth case. If it's in between 0 and 1, then we're in a decay. If we're using base E, then K has to be bigger than 0 in order for it to be a growth. If K is positive, and we are decaying if K is negative. Good times. Give you guys a couple of seconds to write those in. Okay. Let's graph 2 of these. I am going to change this function. I want this function to be 4 times 2 to the 0.5 x power is what I want. Because then we don't have to have 2 with e in it. So, okay. So we'll do that one. So we'll graph that one instead. In your notes, sketches are just fine. Just fine for these. Okay? It doesn't have to be, you don't have to spend the next 5 minutes drawing yourself out a piece of graph, a graph with all the graphing lines and all that stuff. Just fine for a sketch. All right, so example number 1, 4 times 2 to the 0.5x. Okay? Growth or decay? Thumbs up growth, thumbs down decay. Ooh, we're kind of mixed on this one. Okay? So this is of the non-E version, so we need to look at this value right here and that value right there only. Okay? If that value is bigger than 1, it's a growth. If that value is less than or between 0 and 1, it is a decay. So this is a growth function. Okay? So it's going to start out low and go high. Okay? We have no vertical shift. So that tells me then that our horizontal asymptote is at y equals 0. If I found the y-intercept, I would plug in 0. 0.5 times 0 is 0. 2 to the 0 power is 1 times 4 is 4. So we would be at the point 0, comma 4 for that. Okay. If you wanted to find more points, I would pick 2 as my next value to go in. Because 2 times 1/2 is 1. 2 to the first power is 2 times 4 is 8. Likewise, the next one I would pick if I needed to, I would go 4. Okay? And 4 would be at 4 comma 16. Good? All right. Next one, example number 2. Thumbs up growth, thumbs down decay. Growth or decay. This one, see, this is where that E comes in nice and easier too, right? If the exponent's positive, it's growth. If the exponent is negative, it's decay. Okay? So this is a decay. So this is going to start like that and come down like so. Horizontal asymptote. Y equals 0 or y equals something else? What are we thinking? You can either type it in the chat or you could unmute yourself. What are we thinking for the the horizontal asymptote? Y equals... I see a couple of people hopefully giving... What you got, Jaden? Yep, that's right. Yep, I was just about to say I see some people are giving me a good finger, not the bad finger. A lot of people were giving me that symbol in the chat. Yep, so we got y equals 1 is our horizontal asymptote. Okay. What is our y-intercept? 0 comma what? Might have to use 2 hands for this one if you don't want to unmute yourself or if you don't want to type it in the chat. Okay. 0 comma what would be our y-intercept? Negative 2 times 0 is 0. E to the 0 power is 1. 1 times 14 is 14. 14 plus 1 is 15. Yeah. Okay, so 0 comma 15 is our y-intercept. And to be honest with you, I'm okay with just that one, especially on these E-graphs, because the base isn't very nice, because it's a non-repeating decimal that goes on forever and ever and ever and ever. I'm okay with just that as your graph. Okay? That, ladies and gentlemen, is all that I have for you today. This week, so looking forward to this week now. Tomorrow there's a video posted on It's Learning Already that goes into logistic functions and solving logistic functions. Okay? Excuse me, not solving, just what a logistic function is. Then Friday there will be a logarithmic video about some properties of logs, because we need those to do what we need to do with exponentials. Then Monday, there will be another video about expanding and condensing logs. And then for the next 2 live classes, we will be solving logarithmic, exponential, and logistic equations. Yeah, so that's where we're at for right now. Okay? So that's like the next week. So we're dealing with logs and solving, and we're getting into the good stuff with math. And then once we get done with this, then we're looking at getting into some trig stuff. So, okay? Thanks for playing along. Have yourselves a great, grand, and wonderful day and good rest of the week.